Assalamu alaikum everyone. This is Sir Shakil Mahmood, physics A-level teacher and subject head of Roots IV International School Systems. Our today's video is about our first practical that we have done in our school, um, both for Group A and Group B. What I'm going to do today in this video is to solve this whole practical for you so that you can look at the method how to solve the practical, and then you can compare my work with your work to look out for your mistakes or problems that you have encountered while doing the practical or while solving it. So beta, we know that every practical consists of two parts. Part one is the apparatus setup and using the apparatus to take the readings. And there are always sets of reading, two types of reading that you have to take using the apparatus. One is the independent variable or the independent quantity that you're going to change yourself, and then the second one is dependent quantity, the quantity that will be changed as a result of the change in independent quantity. And then beta, the second thing is the calculations. After taking all the measurements, you have to do you have to calculate many things. You have to make graph, you have to draw a table, you have to use straight line equation to look for some values of some constants in the practical. So mainly every practical consists of two things. One, taking reading using appropriate instrument, and the second one is the calculations. Okay, in measurement, decimal places are important. You need to write, you need to express your measured values in same decimal places as the number of decimal places in least count of that instrument. Secondly, in calculations, the significant figure are important. So if you want to calculate something, then you need to express the answer of your calculated quantity in same number of significant figures as in the raw data. Okay, let's move on to the practical now. This is your question one, and this is your instruction page. Obviously, you have to read carefully your instruction page. So let's say I'm going to write my name on it. Okay. Okay, let's move on. This is Advanced Practical Skills 1. And beta, these are the instructions. You need to read these instructions very, very carefully. Okay, then the things that you required in this paper is, of course, blue or black pen, a lead pencil, sharpener, eraser, and a ruler, and a calculator, of course. Let's move on to the part one. After setting up the apparatus as shown in the figure, you need to look for some measurements. So the first measurement is the height. So measure and record the height h. So this is height h, which is between ground and the top end of the string. So you have to measure this and you have to express your answer over here. Second, you have to measure and record the value of x. So x is the distance from center of pendulum bob to the bench. Okay, so let me write these values. Let's say I have kept the value of h as 91.5 centimeter, and x comes out to be 5. I have kept it exactly at 5. So a point to be noted over here is that these two are your measurements, and you have used ruler to measure them, and the ruler is having a least count of 0.1 centimeter, which is having 1 dp. So it means that every reading that you are going to take using this ruler would be having 1 dp, like this and this. So these two values is expressed in one decimal place, like 91.5. So zero point 0.5 is one decimal place. Similarly for x, you have to write 5.0. If you are just writing this as 5 centimeter, like x equal 5 centimeter, then this value would be considered as incorrect. So this is the correct way to write. Okay, let's move on. The next thing is you need to look for the time period of the pendulum, and it is said that you need to determine the accurate value of your time period. So accurate value of the time period. Okay, how to how to detect the accurate value of the time period? First of all, what you have to do is you have to select number of oscillations like 10. So you are going to measure time for 10 oscillations, right? And let's say your first time is coming out to be, for 10 oscillations, your first time is coming out to be 18.90 seconds. Okay, the stopwatch that we use is having 2 decimal places, right? So as it is having 2 decimal places, so I'm going to write all the time measurement in 2 decimal places. So again, I swing pendulum for 10 oscillations and time comes out to be 18.91. And for the third time, when I repeat this, it comes out to be 18.88 seconds. Now the next step is I have to take average. So how I can take average? I can add all these and divided it by 3. So after adding, my answer is 18.90. Okay, after doing this, I have to find time period, which can be determined by dividing average time with number of oscillations. So as number of oscillations are 10, so when I divide it, my answer comes out to be 1.890. Okay, let me tell you a special thing over here in this case. What you can do is that this is only for time period. This thing that I'm going to share is only for time period. Okay, in the time period, you have to write your answer in same significant figure as in average time, or you can also write one less significant figure as in average time. So beta, this condition is only for time period. No other quantity is given with this condition. So normally we write same number of significant figure or one more than the same, but in time period, this is exclusively for the time period. We can write our answer in one less significant figure as in average t. So look, in average t, 4 significant figures was there, 4 significant figure. So we can write our answer in 3. So I'm going to write 1.89. Even if you write your answer in 4 significant figure, that will also be considered as correct. 1.890 is also correct, or you can write one less significant figure as well. Okay, beta, let's move on to the next thing. And over here is keeping age constant. So keeping age constant is that the height that you kept at 91.5 centimeter, you don't have to change it. Just keep it constant and change x. So change x and repeat A3 and B until you have 6 sets of values of x and t. And then he said that include values of t square in your table as well. So look, I have shared a table from someone. Let's say the first column is serial number 1, 2, 3, 4, 5, 6 readings. The second one is the quantity, which is independent variable x along with its unit. The next one is the time period. You can just mention over at the top that the number of oscillations are 10 for these. Okay, the next one is time second time for 10 oscillation, and this is the third time, and then beta this is the average time. So till here are your calculation measurements, sorry, these are your measurements. Okay, then this time period and the square of time period, these two are your calculations. So if you look carefully upon the data, it is the first one is, let's say, this one, this is second one, this is third one, this is fourth one, fifth one, and beta sixth one. So the first reading is 5.0, then 15.0, 25.0, 35.0, 45.0, and 50.5.0. Let me tell you a very, very important thing over here, and that thing is related to X. Important about independent variable. How do you know that you have to take readings from 5 to 55, or how much gap you have to keep between these readings? So beta, let me tell you one thing, that there should be constant gap between the independent variable. So constant gap between all readings for independent variable, which in this case is X. So what is the gap? The gap is 10, 10, 10, 10, 10, and 10. So beta, there is one mark. This mark is the quality mark for, or quality mark for your independent variable. So you will be awarded one mark if you keep the gap constant. You can't do it like 5.0 and then 13.0 and then 20.0. You can't take data like that. Second thing is that your range should be good. Range of independent variable. How you will see that what should be the range? Look, you are going to measure X using a ruler, and the ruler is having 100 centimeter, right? So you have used the ruler 0 to 100 centimeter. Okay, so for X your range should be at least half of your meter rule. That is, it should be greater than or equal than 50 centimeter, right? So how you can determine that your range is correct? Look, what is the least reading? It is 5 centimeter. What is the maximum reading? It is 55. So just subtract them. So when you subtract them, your answer is 50. So 50 is touching the range. But if you take first reading as 5 and then last reading as 35, so your range would be 35 minus 5 is 30. So that is not fitting in the range. So you will be losing your range mark, right? So what is important in independent variable X, that you should be utilizing maximum part of your meter rule, and the minimum requirement is that the difference between your first reading and last reading should be equal to or greater than half of the length of the meter rule, right? Okay, then beta, all the time periods are given. You oscillate it for 10 oscillations, and you have to repeat it, and all the measurements are over there. So these are all the measurements which are listed for T1, T2, and T3. Okay, so then you take the average value, T1 plus T2 plus T3 will give you this average value, and then you divide this average value with 10 to get the answer. And if you see carefully, last two things, significant figures are important. SF is significant figure. So in time period, I already told you that you can keep significant figure one less than the average time. So in average, there are 4 significant figures. So you can write in 3. So 3 is fine. Again, in the second reading, these are 4. So you can write in 3, 4, you can write in 3, 4, you can write in 3. And then in T square beta, you just need to take square of this T. And in T, there are 3 significant figure, in T square 3. In T, there are 3, and in T square it is 3. So you need to keep significant figure same as it is in the raw data that you are using to find anything. So beta, in short, in X, T1, T2, T3, and average time, decimal places are important. So down the column, same decimal places should be there. Like in X, 1 decimal place, in T1, 2 decimal place, in T2, 2 decimal place, in T3, 2 decimal place, in average time, 2 decimal place. And then in the last 2 columns, time period and T square, these are calculations. So your significant figure should be same. Okay, let's move on to very important thing, which is plotting a graph, right? So what you have to do is you have to plot a graph of t square along x-axis and x on x-axis, and then you need to draw the best fit line, and then you need to determine the gradient and y-intercept of this best fit line. Okay, so let's draw the graph. The first thing in graph is labeling the axis with quantity and unit, and this is for 1 mark. So as along x-axis you have to take x and it is in centimeters, so you can do it like this. And along y-axis you have to plot t square slash its unit second square, and it's like this. So beta doing this will give you 1 mark. Okay, now the next thing is scaling. Scaling is the process of giving value to each square, each big square along x-axis and along y-axis as well. So I've already marked these points because it was hard to see in the graph. So I have marked these tiny dots, tiny lines to represent each big square. So there are 8 big square along x-axis and there are 12 big square along y-axis. Okay, so what you need to do is you need to scale it now, right? So for scaling, let me tell you something about scaling, how to do scaling. Okay, so let's do scaling. And for scaling beta, we need to use this value again, and I will be doing scaling at the very end of the graph so that uh, yeah, so that you can understand it in a better way. So let's do scaling. So let's do scaling first for x-axis. So in order to do scaling for x-axis, you have to select a range of scale value, SV scale value, and range contains minimum scale value and a maximum scale value. I've already told you, but I'm telling you again. So this is your main formula. In order to get the minimum scale value, the formula is maximum of the quantity that is going to be plotted along x-axis minus minimum of the quantity, you will get this from the data from the table, divided by number of squares, which are 8, right? And then maximum can be calculated simply by minimum scale value and multiplying it with 2. So let's select the scale value now. So what is the maximum scale value along, because this is to be plotted along x-axis. So this is maximum value 55.0 and this is minimum value, which is 5. So what you will be doing is 55 minus 5 divided by number of squares are 8. So just solve it. It will be 50 over 8, and then this will be approximately 6.25. Okay, then the maximum scale value will be 6.25 into 2, so it will be of course 12.50. So for x-axis, the range for scale value is 6.25 to 12.50, right? So what you have to do is, after this, pick any number from it. Pick any value from range. And just make sure that you should not be picking 3, 7, and 9. So you have to avoid these numbers. So, well, my number is, let's say, 10. My number is 10 because 10 is falling over there. So what I will do is I will keep the value of each big unit along x-axis as 10. Now I have to see that what is the smallest value along x-axis. The smallest value is 5, right? The smallest value is 5. So I can start the origin from 0. So this is like 0, 10, 20, 30, 40, 50, 60, 70, and 80. So my scale values are done. Okay, now I have to look for the scale value along y-axis, right? We have to look for the scale value along y-axis. Okay, let's move on and look for the scale value along y-axis. I'm going to use this diagram uh, again. Okay, for y-axis, these are plotted along y-axis. So y-axis scale value. Again, you have to select a range of scale value for y-axis, and that is like minimum scale value and then a maximum scale value, right? And minimum is again maximum of the quantity, that is t square, minus minimum of the quantity, that is t square, divided by number of squares. And then maximum scale value is simply the answer of minimum scale value into 2. So let's put in the value. So what is the maximum value? The maximum value is 3.57. So it is 3.57, and the minimum value is 1.51, and number of squares along y-axis are 12. So what you have to do is you have to solve it, right? You have to solve it. So let's solve it now. Okay, so it is 3.57 minus 1.51 divided by 12. So your answer is coming out to be 0.17. Okay, and then it is 0.17 into 2, so obviously 0.34. So your scale value range for y-axis is what? It is 0.17 to 0.34. So what you have to do now, you have to pick a number from this range, right? So what's your number? My number is 0.20, because 0.20 is coming from there. It means that along y-axis, I will be giving a value of 0.20 for every big square. Okay, now look for the smallest value. The smallest value is 1.50. So this value is not closer to the 0. It means I'm not supposed to start from the origin. The origin from the 0. So I am going to start my origin for y-axis from a number that is very close to 1.50. So let's get back. Let's get back to the graph. Okay, here is the graph. So what I'm going to do is, first I'm going to check that whether all of my data will be plotted along y-axis or not. Let me tell you a trick. Trick to check scale value validity. This is very important. Okay, so what you should be doing is you should be writing your origin value plus your scale value into number of squares. So let me start my origin from 1.40. Scale value is 0.20 and number of squares are 12. So 1.40 plus 2.4, right? So the answer is 3.80. So now look for your maximum value. Look for maximum value of t square. If the maximum value is less than 3.8, then you can use this origin value and you can use this scale value. So what's the value? That is 3.57. That is way less than your answer. So it means that it is confirmed that you can use this scale value and you can use this origin value as well. So let me start plotting the graph. So I'm going to take this as 1.40 and then 1.60, then 1.80, then 2.0, then 2.20, 2.40. Okay, and then 2.60, 2.80, 3.00, 3.20, 3.40, 3.60, and finally 3.80. So beta, doing this, why we have done a rigorous method, a longer method? Because you need to utilize maximum part of the graph. So the only way out is using scaling, right? If you use this method, then you will not be losing any quality marks in the graph. Okay, beta, the next thing is, like, we're done with the scaling, we are done with the labeling. So what is the next? I can write it over here. In graph making, which points are important? First is labeling, the axis with quantity and the unit. Next is scaling, giving value to the origin and to each square. Third is plotting. And fourth is drawing line, drawing best fit line. So we are right now done with these, and we have to do plotting now. Okay, so every one of you is very well aware of how to plot the values. So let me quickly plot these values for you. If you look upon the first, x is 5, and then this is 3.57. So x is 5 and 3.57. So 5 and 3.57. Okay, so along y-axis, each big square, like I can write it for y-axis, each big square is equal to 0.2. So each small square is equal to 0.02 then, right? So where should be 3.57 lying? 3.57. So 3.57 should be lying right over here along with 5. So I have drawn a tiny dot and then a small square. So beta, this circle, sorry. So this small circle should be within the 4 small square. If you look closely, if you can look closely, I have drawn this red circle within 4 small squares, right? Because that is the accurate way. You can't draw bigger circles. Okay, let's move on to the next value. What is the next value? Let me make it a bit bigger. Okay, the next value is 15 and 3.29. So let's move on to 15 and 3.29. So 15, okay, 15 should be 1, 2, 3, 4, 5. 15 should be here, and 3.29. Okay, where is 3.29 located now? So 3.20, and well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So 15 was over here, and 3.29, 3.22, 3.24, 3.26, 3.28, and 3.29 is over there. So this is the point, and this is the circle. So this was the second point. Now look for the third point. The third point is 25 and 2.82. So 25 and 2.82. So 25, okay. 1, 2, 3, 4, 5. 25 is over here. And then what's the next value? Next value is 2.82. 2.82. So 2.82 and 25. Okay, I just want to trace this 25 because over here the lines are very much congested. So 2 point, I forgot what was the value, 2.82. Okay, 2.82 beta, it's somewhere over here. This is the dot and this is the circle. Okay, 2.82. Okay, what's the next value? What is the next value? It is 35 and 2.34. 35 and 2.34. 35 and 2.34. So 35 is like 1, 2, 3, 4, 5. Okay, so this is 35 and 2.34. 2.34. Okay, beta. 2.34. So 35 is this line, and 2.34. So this is 2.20, 1, 2, 3, 4, 5. This is 2.3, 2.32, and 2.34 is somewhere here. Okay, so this point is also plotted. Let's move on to the next one. It's taking too long now. For 45, it is 1.88, but we are at the end now. 45, 1.88. 1, 2, 3, 4, 5. So this is 45 and 1.88, 1.80 and 1.82, 1.84, 1.86 and 1.88. So this is the point. Okay, and the last point is for 55, it is 1.50, 51, sorry. So for 55, 1, 2, 3, 4, 5. This is 55. No. Okay, this is 55. So for 55, it is 1.50. So 1.50 is somewhere over here. Okay, beta. So what you have to do now, is you have to draw the best fit line, right? You have to draw best fit line, and I can't draw it on it now because of the unavailability of the ruler on this. But what I can do is I can just try. Okay, look, for the best fit line, beta, you should be fixing your ruler. Actually, the thread method is the best one. You should be using thread, and you have to stretch the thread along your plotted points, and you have to look for the maximum number of points coming on your line. And then you have to look that if some points are not coming on the line, they should be equally distributed along the line. That line will be considered as the best fit line. So what I am going to do is I'm just sensing that what are the points that are coming on the line. So let's say this is my best fit line. So well, I have just drawn it by freehand. Actually, what you will be doing is you will be drawing this line with the help of a meter rule, of course, or a scale. So your line of course would be a best fit line. So if you look, let's imagine that this line is straight line. So all the points are coming on the line, only one point is above, like this point is above and this point is bit below. So the point that is too far, you can just label is at anomalous point, right? So this is we are done with the part 1 and part 2 as well. Okay, the next thing is you have to determine gradient and y-intercept. So beta, for gradient, what you will be doing is y2 minus y1 over x2 minus x1. So what you have to do is you have to select any 2 points on the line. These can be the already plotted lines if they are coming on the line. If any plotted point is not coming on the line, then you can take any other point of your best fit line. But make sure that the point that you will select on the best fit line should be more than half apart, half the line length apart. Let's say I have selected this is x1 y1 coordinates, and then I have selected this one. This is having coordinates x2 y2, and what I have to do is I have to draw a line like this, right? So now just fill in the values, 1 2 3 4. So this is first and fourth point, okay. So first point and fourth point. Okay beta, so what is y2, that is t square, for fourth point, that is 2.34. What is y1? That is 3.57. What is x2? That is 35. And what is x1? That is 5. So what you have to do is you have to subtract them, right? And you have to find the gradient. So let me work out for it. 2.34 minus 3.57 divided by 30, it will give you minus 0.041, minus 0.041. So this is the value of your gradient, so you can write it over there, no need to write the unit. Okay, then beta, for y-intercept you will be using y equal mx plus c. You will always use this equation, right? Now you have to select any one point, so let me select the first point. For first point, what was the value of y? It was 3.57. Gradient you have already calculated, minus 0.041, m is gradient. And what is the value of x for the first point? It is 5, and plus c. So c is your y-intercept. So what you will be doing is 3.57, and then you'll be taking this value to the other side, so it will be plus, and then it will be 0.205. So when you add them, when you add these two together, 3.57, your answer will be 3.775, or you can write 3.78. So that's how you can calculate your y-intercept. Okay beta, the last thing is this one. An equation is given and a and b are constants, and you need to be using answer to d3. D3 are the gradient and y-intercept answers, and you need to find value of a over b, and you have to give a unit as well. So 1 mark for this calculation and 1 mark for writing the unit. So beta, how you will do that? Just write down this equation, and then beta, uh, you have to compare it with y equal mx plus c. This is straight line equation. So I'll be writing t square equal minus bx plus a, and when you will compare it, you will see that this is plotted along y-axis, x is plotted along x-axis. So we can say that this gradient is equivalent to negative b, and the y-intercept is equal to a, right, in the comparison. So you will simply write that, look, your value of a is equal to y-intercept, and what was the y-intercept? It was 3.78. So 3.78, and the unit for y-intercept is second square, because along y-axis second square is plotted. Okay, for negative b, it is equivalent to gradient, or you can write b is negative gradient. So this negative, and what's the value of gradient? Negative 0. Let me see, 0.041. 041. So when you multiply it, your b will be plus 0.041. And what is its unit? You know, gradient is y over x. Along y is t square, along x is x. So t square is having unit of second square, and x is having unit of centimeter. It means the unit of b will be second square per centimeter. Okay, now what you have to do is you have to divide a and b together, right? Let me do it over here. A over b. So beta, what was a? What was a? A was like 3.78, and its unit is second square. And what was b? That was 0.041, and its unit is second square per centimeter. So this second square goes away, and then what you have to do is you have to divide 3.78 with 0.041 to get your answer, that is 92.19, and this is centimeter, right? So you can write it as 92.2 centimeter. So beta, that is your answer. So I hope that, well, the data that I have taken is was taken by a student in the lab. So you can expect some error in the data, but you can, if you have not taken your data, then you can print out a paper and you can use the same data to solve the paper. But if you have your own data, then you can look for the accurate method of table drawing, for taking the reading, for decimal places, for significant figure, how to draw the graph, how to find the gradient and y-intercept, and how to do the last part. So doing this will help you a lot. So I hope that every one of you um, would have been benefited with this video, and you need to make correction in your work. And inshallah, in the school, I'm going to see how you have done your corrections, or how you have completed your practical calculation on the basis of instruction I shared in this video. So take care, everyone. Inshallah, see you in school. uh, Try to remain happy and try to bring smiles on others faces as well. Okay, take care, everyone. Allah Hafiz.